We have an Excel sheet data that have longitude and latitude,
Okay,
and this is a 3D. This is coastal thickness and density, so it's like a 3D data. So we are going to use this, and like I told you, anytime you have a data of longitude and latitude and another point on it, which is the Z component, another Z component, and you have another Z component, another Z component, you don't need to separate them in different Excel sheet. All you need is bring those datas in. So I'm going to make this one the Z1, and then I'm going to make this one the Z2. So that is one. So if you have this longitude and latitude, so you don't need to separate them in a separate sheet. So I am going to save it as CSV. So I'll save it as CSV, and I will make it like I'll write your name. So we want to like work on 3D. So I will save it up here. So it is saving. So the point is almost about the total length of the data is closely about 300 and something thousand. That's 324,000. So I am going to here, which is file. I go to add data. I go to add data here. So to get to the location where I save the data, this is where I save the data, and you can see it here. So I will come here and copy the directory. Then go to here, click on add the data, and when this open, I will have to paste the directory I copy so that I'll get there quickly. So I am here. So you can see the data here, and I'll click on add. Now the longitude, the latitude, the Z component, I just have to choose the Z1 first, and I will have to put them in geographic coordinate system. Now I have defined the coordinate system. If you want to see more details, you click here, you can see more details about the geographic coordinate you're using. So once you are done, you click OK, and it will ask you this kind of question. Click OK. Now that's going to take time because the data is very big. Yeah, so it's going to take a bit time, and it will be added here. So you can see it is a density, it is a very big data. You can see the number of points as it is. So this is it. So if you don't have speedy laptop, you might have problem with the data.
okay.
Yeah, so now this is it. Now this is the point. Like I told you, if you open the attribute information, you will realize that the data here is about this. It's shortening it up to 200 because this means that there is more to it, more than 200. But like I showed you here, it is about 300 and something file here. As you see, there's 324,086 points. So this is big. So for me, I am going to make selection like for illustration, and that selection, so let me export, let me save this first. So I will go down to the same location, and then I will paste the directory which I copy because I want to get to the location fast, and I will click on save to bring me to ArcMap. So I am going to make it here. So I'm going to put today we are working on points. So I will save it here. Now for me, I want to make select those data. So I'm going to export this particular one now to save it on the same location. Click on home, and then I'm also going to make the point here. Then I will save it. Now I'm waiting for it to export. So what I could do is I am going to select some of the points here so that I will not have this number of points that is probably going to take us time. So but why I decided to use this kind of big data is that if you are using larger data, you are going to have so much congested point. So you
Oh,
need to understand what I'm saying, because for example, if you see a LiDAR data that is in up to 1 centimeter, so you will see that is a problem. I have a LiDAR data of Enugu, and it is up to centimeter, to the extent that for you to load a plot of land becomes a very big problem. A data in a plot of land, because it is really much. So as you can see here, this is a very big data. So I
okay,
wanted
sir.
you,
Is this for a LiDAR data?
you saying?
Is this also a LiDAR data?
It's a cluster data, though it is
Plus,
in, yeah, it is in that form, because LiDAR, it can come in different ways. Yeah, so but what I wanted you to understand here, what I mean here is that it's is a point that is very cluster. Like if you check the distance between them, you see that it is really like well clustered together. Like this is what I mean. I'm going to zoom to the level of, this is 1 is to 250, this one is to 50. Now if I zoom out a bit, this one is to 250, one is to 500, you see that this place still have points as it is loading. So let me change this to a smaller size and make it
bye.
like 1 here, and change it to something like 1, click OK. Now if the data is still loading, so what I mean that is that, like, this data is up to centimeter level. You get what I'm saying?
Yes, sir.
Yeah, so it is up to centimeter level, so the data is really clustered. So if you keep zooming, you see that, you can see that the data is well clustered. So this is what I mean. So it is a very big data that you can see now. Can you
Oh,
see? So it is well clustered, and if you look close, you see that this is the from here to here. So if you take your measurement to pick this
okay.
point to here, you can
You get
see,
the
so it's in
the
geodesic. So it is well clustered. So, and what I'm going to do is that I'm going to take it off, and I want to select some point. So I am going to select, probably using a line. So in selecting using a line, I'm going to draw across it. So I wait for it to load, or probably I will need to change data, because what I wanted you to understand on this is that, one, when you're having two datas, like datas that is in Excel, like this first thing I wanted you to understand, that number one is that if you have a data that have longitude and latitude and other variables related to Z, you don't have to split them into this one to this one, like longitude, latitude, and first one, to work with it, and then you go and bring another one, longitude, this and this. I don't know if you get what I'm trying to say. Like when you were talking about with the air quality data, you don't need to separate them. You
okay.
get?
Yes,
Yeah, so
yes.
this is
I
what, yeah, this is what I want you to understand on this. So you can bring all those data together, and when you bring them together, you
you just
select
what you
a
want.
column you want. So on this, because this is likely going to take us a bit time, so let me quickly get. Okay, so on that, I want to, this is a comma delineated data, so I want to turn off this. Still go to the file here and go to add data, then click on this, still return back to the same place we are, open it up here. This is the easting, this is the northing, so this is in UTM. So because of that, I am going to change the coordinates, so northing, and this is the Z component. Now I am going here to change this to UTM zone 32 and click OK. Now first and foremost, I want to remove this data for now. So let me remove them, and I will go to the property here. You can see if you go to the property and go to the coordinate system, you are going to see that this is WGS. So I want to put it in UTM because I want to work in a smaller, like I'm working with Enugu data. So I'm going to add points the same way you add your point. Then I'm going here, select this one, which is what I'm interested in. Then put this thing in not. Then here I have Z, which is the Z component. Now this automatically is in projected coordinate system. And then I will click OK, and that will export the data. Now this is the work here. Now the next thing I need to do is to export it. This is now so that I will make it in shapefile. So here I'm going to put this at points. So when this is done, so I have this because this is an event file. So I will need to have it as a shape file for me to work with it. So I will remove this event file. Now we have this. Now, on working with points, there are different things you can do with the point. The first thing we are going to talk about now is if you talk about the density, you are going to talk about density. We are going to talk about, like somebody asked you to create a density map or hotspot map, or another thing we are going to talk about is we are going to talk about interpolation. Then we are
Okay.
also going to talk about creating the contour, that is thin. So on that, so the first thing we could do,
It's a lot of rainfall something. It's not this type.
you say?
Rainfall analysis.
Yeah, we'll have that, and we'll go into that. We'll have those data too, so you can also use that. So rainfall can come in different ways. It can come like a net CDF file. Rainfall can also come like a CSV file. Rainfall can come also like a raster file. So each of those of the file, we are going to like look at each of them. So about like I said, this is just like a CSV point.
Okay.
So we will finish with the CSV point, then we will go to the other file, like the raster aspect of it, and we're going to also use the next CDF. Is that
Okay.
okay?
Yes, sir.
Okay, so now you see here, I have this point here. So I am
Yes, sir.
going to go to Arc Toolbox here. The next thing I need to do is I will need to convert this to thin. You get that?
Okay, from data management.
Yeah, so I'm in 3D analysis here, 3D analyst tools. So you see this is data management, this is team. So you see here, data management,
Okay.
3D, data management. I open data management, I see team. So I want to create team. And
Okay.
team is simply regarded as triangular irregular network. So it is
Okay.
going to use this to triangulate within each like of them and bring a network with this. So I'm going to use the data. Now if you see here, it creates a triangulated irregular network data set. Now the output, I want to leave the output wherever it is, but I can still save it where I want to save it. Now which data do I want? I'm going to select the point here. What is the Z feed? You can see here the Z feed here is Z. You can see this Z feed here. Then input the coordinate system, input data, which is what I input here. The coordinate system, this is optional, so I can still select this to make it here. Now once I am done, I will click OK. Now this is going to create an irregular network for me using this data now. So if you check results current, you can see that it is still running here. So it is still trying to create the irregular network for me now. So we wait for it, and it will be done soon. So it's still creating the theme, and this sign here means that it is still creating. So
Okay.
now this is done, and
Um,
if you turn this off, you can see it have created the triangular irregular network for me. So you see here, you can see different regular network that you have created, and you can see this is the elevation on how it's come across them. So you can see the way it's created it. So now after this, the next thing you can do is to still return the same place here. I've created tin. Now I will
Okay.
go back to conversion, and I want to convert from tin. So I will go convert from tin to raster here. So I will open it up here, and I will select that thing I created, and I will leave this raster by default, and I will click OK, and then it's going to convert this thing for me to raster.
Okay.
So it is going to make it to convert it from triangular irregular network to raster. So you can see here the same thing we have here. So I'm going to turn this off, and you can see this is the raster pattern of it. So it's still the same thing we created. So let me change this into elevation and click apply, and this is what it created. So similar to, you can see this.
Okay, the raster is the point.
Yeah, the raster now, it is now making it in raster, because this is when it is in raster, this is when we'll be able to extract like elevation information like contour from it.
Okay,
Is that okay?
sir.
Yeah, so this is a way it goes. Now in image analysis, which I'm going to talk to you when we are creating raster, if you look at the raster now, if I change this thing to bilinear, now you can see how soft and smooth it is right now. The reason is that when
Okay.
it,
So
yeah,
you right clicked.
no, I went to image analysis. Image analysis. So that's why I say I'm going to tell you much about it later. Okay?
Okay.
Yeah, so now this is, you can see this here. It is the percentage clip here. If this is nearest, which uses 4 points, you see cell, each of the cell it uses 4, like one neighborhood of 4 points. Now when I change it to bilinear interpolation, it goes to 16, and when I change this also to cubic convolution, you can see the way it looks. So we are going to talk majorly well about this when we'll be talking about raster. So you see here, this automatically gives me this. Now you can see the way it looks. Now the next thing I'm going to do is I'm returning back here, and I'm going to here close the 3D analysis, and I'm going to spatial analysis tools. Now in spatial analysis tools, I will go to surface. Then with surface, I want to create contour. Now I'll bring in this here. Then I want to put the contour interval. I can make this contour interval. If you make it 1, let's use 1 meters interval. Now when you run the 1 meters interval, you see that it's going to create a contour 4 meters interval for you. Now this is what it looks like, 1 meters interval here. So this is 1 meters interval of the contour you created using tin. Now, if you look at the contour, you see that this contour is not smooth, it's not curved, it looks like we are fighting with it. You can see the way it is. So if you want to line smoothing, go to cartography tools here, go to generalization, go
Sir,
to,
you have to, sir.
you say?
Yes, sir.
Yeah, under
Okay.
cartography tools,
Cartography tools. Okay, sir.
go to generalization here.
Okay.
Then go to smooth line. This is
Okay.
where you smooth sharp angles in a line to improve the aesthetics or cartographic quality.
Okay,
Now,
sir.
I am going to input this here. Now, it asks me what is the meter, that is smoothing tolerance. This is to preserve the endpoint for the closing point here. So set a tolerance used by the peak algorithm. The tolerance must be specified and it must be greater than 0. You can choose a preferred unit. The default to this point is feature unit. You must enter a number greater than 0. So now in the smoothing, you see here, look here, see this is not curved well. If you look here, you see that, see, You can see the way
Yes.
this is looking. So now let me make it like I want to smooth it by 5. So let me use this as example. When I run this, you will see the difference between the contour that I created earlier and what the smoothing does. Now let me give you example. You see the difference?
Mm.
So if you look at this, let me change this into blue or to another color. So I'm making it red so that we see the difference between them. Now look at these two contours.
Mm.
So you see this is well curved. This
Yes.
is not well curved. So this is a way you can see here. You can see how this goes. This
Yes.
is well
Wow.
curved. So you see here, you can see the way this one
Wow.
goes. Now this
Yes.
is well curved. So you do your smoothing. Now this makes the contour improve in geometry and look better than what it is now. You can see here. So you just make it looks better than what it was. See, this bring have a very sharp curve. Now that's for that. Now you see now that we have ended up creating a contour, as you can see. So if I have a boundary, I can clip and remove it. Now if you go to the contour property here, you see that it have added the contour interval here because we use 1 meters. So it have added the contour interval here. So I can right click on this and label it. And when I label it, it shows me these values. So I can now go in here, go to the properties, go to the labeling tab, and in the labeling tab here, I can select that I want it to label with the contour, and I want the placement. I will say put it on the line, then I will click apply, and I will click OK, and that is going to put each contour interval. So you can see here.
These are the point
You
you
say
are
what?
doing that. The points like the labeling.
Yeah, I'm using the contour that I smooth. This contour that I
Oh,
smooth. Yeah,
okay.
you can see here, this is the contour that I smooth. So I'm using this table, this row, column.
Okay. Okay, sir.
Yeah. So I labeled it and you can see now the contour interval is 147, 146, 145, 144, 143. You can see how it slows in that one. So this is typically a way you can use point to create contour.
Hmm.
Is that okay?
Yes, sir.
Okay, now, second thing, do you have question on this?
No, yes.
Okay, ask your question now before I will talk about another thing.
Okay, sir. Then, what I want to ask is that, okay, how am I going to interpret this contour map? Like looking at it, if I want to interpret it, like okay, there maybe okay, this part means the land is low. Okay,
Okay.
things like that.
Okay, so let's talk about it. So I'm going to turn on this layer that I put up as a contour. And the first thing is that when you are going to interpret this is that where you have this, where the contour is sparse, it means that the level, the ground there is flat.
Oh,
Now,
that.
yeah, their properties as related to contour. When a contour is apart each other, you can see here, it means that this place is flat, fairly flat. It means
Okay.
that between the distance of here to here is about 49, that is about 50 meters, right? So
Yes.
within the 50 meters, there is change of only 1 meter. Do you see it?
Wow.
So it means that the height difference between here to here is 1 meter. It
It's
means
for
that
me.
when the contour is fair apart, it means that it is fairly flat.
Okay.
Now, this is for here, but when the
Okay.
contour is close to each other like this, so it means between the distance of 5 meters, there is 1 meter
Mm.
change. 5 meters. So
That's
there is a
fine.
change in depression, 1 meters, meaning that the contour is very, like the elevation is very high.
Okay.
Yeah, so
But
the perfect example of that is, I don't know whether I can, is Jamboard still working? Because they said they are going to remove, they are going to go with Jamboard. So let me check if it is still on. Okay, they said it's going to be only October 1st. So since we are not in October 1st, let's use it. Okay, so I'm going here. Now look at this. The contour, when a contour is like this is how you notice how the contour looks. So I am going to draw a line like this. Don't mind my drawing, just assume in your head that that is a contour. Now ideally, when you have this, the first thing you need to do is to divide this thing into two. So I am going to make this contour because the way the contour is looking. So what you need to do when you divide this contour into two, and you have a line here, and then this here. So what it means is that, let me assume that this contour have elevation of, this is 100 here. This one
Yes,
is
sir.
100, this is 90, this is 80, for example, and this is 70. Now, when you have here, you have 0 here, you have, let me assume 10, let me assume 20. Okay, because of the size, let's start here with 70. No, let's start with 60, 70, 80, 90,
100.
100. Do you understand what I'm trying to draw? So now, in each of these places, you have 100 here. Now, if you trace this point here, this is where this point is here, and I draw a straight line across it. This is 100. If you take 100 and project 100 here, so I'm going to draw a 100. Let me change the color of the pen to blue. So I'm going to draw, this is where 100 is. So I'm going to draw a 100, project 100 down to where 100 meet here. I want to assume this is where they meet. Then I'll go to 70, 90 here. I'm going to draw 100 here, 90 here, to wherever it meets. This is where 90 meets. I'm going to go here. This is 80. So I'm going to draw from 80 here to wherever 80 meets. Then 70, this one. So I'm also going to project 70 down to where they meet here. Now, for the sake of what we are doing, I'm going to go this way and also do 100. 100 meet here, right? So I'm going to match 100 to meet here. 90 meet here. So I'm also going to make 90 meet here. 80 meet somewhere here. I'm also going to drag 80 to where they meet here. 70 meet somewhere here. I'm also going to drag 70 meet here. So now, this is what I'm going to do. So I'm going to change the pen to red, and I'm going to join this elevation. So assuming that the line goes like this, you see that this is going to turn like this, meet up with here, join this, join this, join this, join this, return like this, and call return back like this. Now, what am I trying to say? If you look at this contour, this will show you that the contour have this kind of value. You don't understand what I'm trying to say?
Yes. Sir, sorry, sir. This 100, 90, 80. Is it the X and Y?
No, the 9080 I am talking about is this contour you're seeing here.
Okay, sir.
The contour, you didn't understand me. The way
Oh,
you
like
responded,
the
the way you responded means you don't understand me. What do you say?
like you drew one contour something, then you now drew one graph. Like
Yes,
one
I am
that
trying
X
to
part is what?
I am trying to explain to you how elevation, how to interpret contour.
Okay, sir.
To know is the contour depressed or not depressed.
Okay.
Do you get what I'm trying to say?
Yes, sir.
Okay. This is what I mean. This is what I'm trying to show you here. So let me use this. Let me look for the right one to use. Okay, so what I'm trying to show you is something like this. See whether this will be faster. You can also use, this is what I'm trying to say here too.
Okay, sir.
Now if you look here, okay, so if you look at this, so I'm trying to show you how you can interpret contour. So if you look here now, you see that the contour here 350, 3500, 3250, this you can see the slope. So if you
Yeah.
look here now, where you see this contour here close to each other, meaning it is changing vertically. But if you look at this, it is sparse to each other,
Yeah.
means that it is
Yes.
have a gentle slope. Now, if you go down here, this is what I'm trying to show you. When
Okay,
a
sir.
contour line is far, when it is far from each other, it means a gentle slope. Do you see this? Now,
Yes, sir.
that is why I told you that here have a gentle slope. Here
Okay.
have a gentle slope. You can see because
Okay.
it is
Yeah.
far from each other. Now that is what I'm trying to explain here. So when far apart, contour line shows gentle slope. Here, when close together, contour line shows a steeper slope. Now, spot elevation are high between contour lines as shown here. Then this is the mean sea level. So this is what I'm trying to explain. Where it is far apart means there is gentle slope. Now let me give you an example here. You can see this gentle slope here. But if you look
Yeah.
here, it is closer to each other, means it is a high slope. So this is a way you can get to understand contour. You can see here the way it is going, and you can see here, you can see
I
this.
get.
So this is a way you can interpret the contour. Now, by looking at the contour here, you can see whether the contour is far from each other or close to each other. So you're able
Okay,
to
sir.
now determine what it is to contour. Now, I think, yeah, this is also part of the things I was trying to explain to you there on how it is done. But what I just want you to understand is get to understand this part. When it is like this, high slope. When it is like this, it means gentle slope. When it goes like this, hilly. And when it is cluster, valley. Is that okay?
Yes, sir.
Okay. So this is how you can interpret the contour. This is a way you
Okay,
can,
sir.
yeah, this is a way you can interpret the contour. So with this, you have created a contour, and if you take out this here, you should be able to have a contour interval that looks like this. And if you remove this from the boundary, you have a boundary to this. So because I think, let me know what I'll bring in the boundary. Let me see where I can bring in the boundary. Okay, so I think let me copy this and import this here so that I can bring the boundary. And so this is the boundary. If I add a boundary, you can see how the boundary look. This is the boundary of interest. So,
Oh,
so you see, this is where we are looking at. So I can
okay.
use trimming or clip. So what am I supposed to do with this contour right now? This is the boundary I'm interested in. So I can go to your processing here.
The process.
Yeah, so this is your processing, or still go down here. Any of them can work. If I'm here, I'll go to analyst tools, go to extract and click on clip. So any of them can work. So here I will select the contour that I smoothen. Feature I want to create it, I can use the boundary and I can click OK. So that is going to clip it only within the boundary. As you can see,
Oh,
it's done clipping. I'll turn off the layer and I will only have the contour
oh, oh,
within here. So if I have a building footprint, I can add the building footprint to it, and you can see where the building are
oh.
up here. Then if I have other features like stream, I can add the stream to it, and you can see wherever the stream falls, you can see the place the water body is located.
Sorry, sir. This building, the building you brought in now,
Yeah.
you've done the digitizing, you've digitized it before.
Yes, that's why I said today I just want us to talk about point. We'll talk about polygon. Like I told you, I'm going to show you how you can get the building footprint, how you can extract them, how you can digitize them, how you can, whatever that have to do with building footprint, I will tell you. But I just wanted you to understand points
Okay, sir.
and how you can use those points at any point in time. So this is the first way. Is that okay?
Yes, sir.
So this is how we are going to create a contour. Somebody asks you, please, I want you to create a contour for me. This is the process, first process you can do to create the contour. And
Okay,
this is
sir.
the contour map. And if you look at the shape of what I have here now, you can deduce the way the lands flow. If you look here, you see that there is a gentle slope here by that contour line on it. There's a gentle
Yes,
slope here that move steeper slope here. There is
yes,
change in elevation here. So if you are looking at this shape file now, you will see how the contour, how it goes.
yes, yes,
Is that
sir.
okay?
Yes, sir.
Now, another thing I want to tell you is using interpolation. So I am going to here, you can see where I am. I'm in Act Toolbox. So this is, sorry, spatial analysis here, and you can see interpolation. Now, I am going to use IDW first. Now, this is basically works where you interpolate raster surfaces. It works perfectly where you don't have much point. I will give you a
Okay,
practical example of what we're talking about. Like, when interpolation is using the one you have to get what is within. Did you understand what I mean?
sir.
Do you understand what I mean by interpolation?
Interpolation. No, sir.
Okay. This is five. This is
Yes, sir.
one, right?
Yes, sir.
I draw a straight line from here to here. Sorry, I'm not good in drawing straight line, but let me try again. My mouse is not working. Now, can I ask you a question?
Yes, sir.
What is the value here?
The value.
What is the value here?
That's 2.5.
Hmm?
2.5.
2.5. How did you know it's 2.5?
Because it's at the center.
Why? How is it at the
It's just,
center?
it's, I just assumed actually.
Why did you assume?
Because it is at the center.
Then I know it's at the center. Why did you say it's 2.5?
It's the half of 5 now.
Half of 5. Why did
Yes,
you know that? Why did you know it's the half of 5?
I don't know, sir.
Hmm? That is what we call that's what we call interpolation. That's what you just did. Do you get what I'm saying?
Okay, sir.
So because you know that this is 1, right? Or this is 0, right?
0, yes.
This is 5. So
Yes.
because you know this value and you know this value, you should know that here is 2.5.
Okay, sir.
So it is called, we call it interpolation. So in interpolation, you use the one you know, like you use the value you know in getting the values that you don't know.
Okay.
So because you know that the beginning of this is this, so interpolation is simply a mathematical technique. Can this calm down? It is rushing. Calm down, calm down. So it's going very, very fast. So but let's wait for it. So you see here, as it says, interpolation is a mathematical technique used to estimate the unknown value that fall within the range of known data points. So that's exactly what you did. So it is widely used in engineering, science, finance, and then let's go to linear interpolation. Let's go to polynomial interpolation. This is span interpolation, nearest neighborhood interpolation. So these are their different types of interpolation. And interpolation based on a formula which we know, which is this and this, x and y, the Pythagorean. So this is just what you did, exactly what you did here, because here is 5 and here is 1. That's how you know that that place is actually 2.5. Is that okay?
Yes, sir.
So what it did is exactly what we call interpolation. So if you have a point here, and you have another point here, and you have another point here, then the value for this point is 1, this value is 5, this value is 7. If I ask you to give me the value here, what would you do? Draw a line here across this, and then here, let's assume here is 4. And then you draw another line across this, whichever way you're going to get it. So whichever way is that you use the value you know to get the ones you don't know.
Okay, sir.
Just like when you are working with GPS, the satellite knows where the location is, another satellite knows where the location is, another satellite knows where the location is, another satellite where the location is, and you are using your phone. How do you know your location? The satellite use ranging, draw from here to here, draw from here to here. This is where you are with your phone, and you want to know your location, or with your GPS. This is what the satellite does. It knows where it is, it knows where it is, it knows where it is, and it knows where it is, but you don't know where you are. So it uses this to determine your location.
Resection.
Yeah, so this
Um,
is the same thing. So it uses this to determine your location. And remember, when you're doing the same thing, in instrument, you have a point here and you have another point here. So you set your digital or theodolite, sorry, total station here. What you need to do when you're doing recession, you sight to this, you sight to this, and automatically it gives you the recession. This is the recession method using total station. So in intersection is the opposite of it, standing on where you know to sight where you don't know. Is that okay? So
yes, sir.
let's return back to what we asked. So we are going to do interpolation. So on this, remember that there is a z value that you're looking for. So once you select the point you want, get the z value and then do the interpolation. So what is it going to do? It's going to create the interpolation for you. That's exactly what we did in the air quality. We interpolated and we were able to get the pattern. So what it does is this. So as you can see, if I turn off this boundary, it gives me the way this looks. This is IDW.
Yes.
So you can still use this to get the value. So now if you open up the thing we created, you see that this is the range of the value, 168, 168. The same value you can see here, 125, 125. So you can use this to get the value, the point you want. The same thing you need to do, you still, after getting this, you go to the surface here, as you see here, and you go to contour, still select the one you use for the interpolation, and then say give me at 1 meters interval, and you click OK, and that's going to run the contour using this one and gives you a contour of the same place. Now let us quickly examine the differences. I'm going to turn off this IDW, and when you zoom close, you can see the differences. Do you see the difference?
Yes, sir.
So we're going to talk about this extensively later, but this is a way you can use. So if you don't have this, you turn this off, you can see the way the contour goes. So I can still go to generalization. Here we have cartographic tools, and I can also go to line smoothing and select this part here and go to IDW contour, and then let's still use the same file we used earlier, and then click on to smooth. Do you know sometimes why I like using IDW? I like using
Okay.
it in interpolation. The reason is this. If you look at this contour, let me clip it first before we talk about what we need to talk about. Yeah, so I'm going to go to IDW, and I'm going to click it with the boundary here and click OK. So that's done, and then I'm going to turn off this and turn off this, and I'm going to have the contour I smoothed earlier. Now let's talk about this. Now this is for both contour. Now this one we have here is the one we created. This is the one we created now. You see the difference?
Now.
Yeah, do you see the difference? The one we created earlier using tin, this is the one we created using IDW, that's interpolation.
Okay, the purple one.
Yeah, this one now, the previous one, the purple, is the one we created now. Do you see the difference in contour?
Yes, sir.
So we are going to talk about those things, so that if it is mathematics that we need to prove it, we'll prove it with mathematics. So you see the same elevation, the same data, but the contour is not on the same place. Now the difference is that the interpolation does a work where it uses both to fill the data, like it does filling, to fill where the data is. Now if you look here where the data is not, if you look here, we have 86 line here on the IDW. If you look here, we have 90. So do you see the difference? And if you look at the drawing, you see the drawing doesn't look the same way. So if you label this, then if you label this one and label this other one, you will probably see the difference between them. But what I just want you to know for now is how you can create a contour map. Is that okay?
Okay.
Yeah,
Yes,
so
sir.
this is how we can transfer.
You said interpolation is better than tin.
In some cases, it depends on the data you have. The interpolation fill the data where it is
Okay.
not existing.
Okay.
So if you bring in the IDW and let us turn the boundary off, and you can see here, you see the difference. So let me bring in the tin we created earlier here. Now look at the difference. Now let me also bring in this which we created, no, not this one. This is tin, this is IDW. Now look at this. I see the difference between them. So we
Yes.
are going to talk about both of them. You see this? So we will talk about both of them like a class. But what I want you to know is that this is a way somebody asked you that they want you to create a contour for them.
Okay,
This
sir.
is the simple step we are going to create a contour. So, and we have done clipping using the boundary. So we are going to talk about how you can use this by adding the building footprint, by adding the road to create a purely topographic map, like the one you used to see in OSCOF.
Yeah.
Yeah, so this is just gradually the way you work with points. Now, if somebody asks you to create a density map, so you still go down to the tools here, you close this up, you go to density here. This is kernel density. This calculates the magnitude per area of a polyline feature that fall within the radius. So if you want to do the this one, so this have to do
Which
with
one is
line.
that with? Sorry. This line density. Is
Yeah,
it
that's,
under keyboard?
I didn't get you.
Is it under app toolbox?
Yeah. Okay, let me go back there. This is what I mean here. Now, this is how I want to see the density of the line, where the line is more congested. So I use this line. I want to see how the line is congested, where it is high and where it is low.
Yes.
So I now use this. You can see it now. Where you have the dark one, so that's where the line is high. You can see here.
Okay.
Okay.
So from app toolbox.
Yeah, from Arc Toolbox, I'm here. The Arc Toolbox, I went to surface. Then
Yes.
I went to under surface here, I went to density. This is kernel density. We use it to calculate the magnitude of point or polyline using kernel function. So I wanted to see what is the density of this line here. Where is the line higher? Where is the line
Okay.
not high? So this is what I can use. So let me change the symbology and let me classify and put it between red and green. So I'm going to put it between red and green. Where you have the red means where the line is higher.
Mm,
If it is where you want to put utility tools, like where you want to analyze the electric wire, where is it having more line or not having? So this place is in danger zone. So if you turn on the line that I use, you will see what I'm saying. You can see. So you realize that the line is high here. You can tell the person that there is a problem here. There's too much electrical line here, or whatever you're analyzing. You should be able to use this to tell the person this is happening here. Is that okay?
okay, sir. Yes,
Yeah,
sir.
so this is when you're talking about line. So this is line density, like I said, you use it to calculate the line. You go to the line here, you select the line of the choice you want. So you use it to calculate when you're talking about line density, where the line is much, assuming that this is a road network. Do you get?
Okay, there is no point.
Yeah, there is no point, assuming that I have a road network. And somebody asks you, where do you have a high density of road? Now, let me know
Like
whether there
for cut
is.
and fill.
Yeah, not really for cut and fill. That's not a good example of what I want to say. But I don't know where I can get the road to show you what I'm saying. But let me assume that there is a road, so I'm going to here to check for road. So highway, land, roads. So let me add this and check whether I will use to explain what I'm saying. So I'm going to zoom to the location of this road. Now this is a road in a particular place. You see this particular place have a less density of road.
Okay.
If I ask you
Yes,
now,
sir.
where do you think we can have higher traffic here?
The center.
So that's at the center. So I can make such kind of analysis using the line density. For example, I will select the road and I don't want to put any population data for now. I want just to leave it by default. Now, by explaining to people what by the probability of if all the cars come out together, where will we experience high traffic? Let me just use that as example. Then I can use this to say where there is too much road, we will have a high density, right? Where there is so much
Yes,
road,
sir.
yeah, there is likely going to be traffic, right?
Mm.
So
Yes, sir.
if there is where there is so much road, there is going to be likely going to be traffic. How do we make those analysis? So I can come up with this type of a thing and tell you that
Oh,
this is where we can have a high density. This is where we are going to have issue with road. Is that okay?
yes.
So that people staying within here will have a traffic issue. So
Mm.
anybody looking at this understand that in terms of hotspot, where do we have the higher density? It's here because there are too much road here. And if you overlay the road on it, you will see that what I'm saying. So there is
Okay,
more
sir.
issues here.
Yes.
So this is for line. We jump into line, but we don't supposed to be talking about line now. We're supposed to be talking about.
Mm.
So if you look closely, you see what is happening. The place that have red here, we have more road here.
Mm.
You can see. Now the place that have any place you see this, there is space here. In green, there is no. You can see here. So if you want to do road extension, it's better to extend road here than here. So, but what I wanted
Okay.
to talk about is points. When we are talking about point here, this is the population. If you have a feed you are interested in, you can use Z feed and then to check the cluster. Now let me turn off this and let me turn off road and let me zoom close to where we have our point. Okay, so let me zoom close to where we have our point. Now this is what I mean here. So let me turn off the contour and this is the density of that point. Do you see, get it now? This is the density showing us where they will have a higher or lower point. So I'm going down to change the color here as well to make it look like this. Now I use the value of the elevation to create this to show where the elevation is higher than the other. So you can see this here have higher elevation, these have lower elevation. Even if you bring in the contour we are using, you will see that here this is flat. Now here it looks lower, higher than others. So this is the way you can create a point density. Do you understand what I mean by density?
Yes, sir.
So do you have issue with the density definition? Now this is another explanation. I'm just trying to show you what you can do with as related to
Yes.
points here. Uh, the real life application can be applied in different places or in different ways. So you can see where the density of the point is high and where it is low.
Okay.
Do you know what we call this is this is hotspot analysis is used to identify and evaluate the statistically the significant spatial cluster of high or low value of data set. Should I give you another example?
Yes, sir.
A perfect example is that if you want to analyze the crime rate
Okay.
and you know that where do you stay?
Now Abuja.
Okay, so let's use Abuja as example. Let's use Gwarempa. Let's use different places. So when you come to Abuja, let's divide Abuja into different zones, zone 1, zone 2, zone 3. And then there is crime happening. And it is said that at any point in time that there is crime, pick the coordinates. Do you get what I'm saying?
Yes,
So
sir.
you now pick such coordinates, and after putting those coordinates together, you realize that, oh, this is what is happening here. That at the end of the day, there is about two people in area one, two, three persons in area two, four persons in area three. Now, if you are asked to analyze the hotspot, where do you have much crime? Where will you say you have much crime?
Here we have more people.
So that's where you have more event happening. So for you to show that, you can give us a kind of but
Okay.
we are going to work on that anyway. So because when we'll be doing analysis, because like I told you, we are going to be following each of these and where
Okay,
it can
sir.
be applied. Like you go to point density, where can we use point density? You go to all of them, where can we? So when you want to analyze hotspots of crime or whatever are happening, this is a perfect example of where how you can use it. So you're able to tell us that there is high crime here, there is a high crime here, there is low crime here. So do you understand what I'm saying, trying to say?
Yes, sir.
Yeah.
Thank
Yeah, so I think if you understand this, we are going to stop here. But this is just a perfect example of what I'm saying. This is crime analysis,
you.
hotspot crime analysis, where you use and say this is what happened here, and there is more crime here, or where there is too much traffic. Where do you have much traffic in Abuja, and you can use that to analyze it like this.
Hmm.
Traffic analysis, you can use traffic to know this is like here, it is high here, it is low here.
Hmm.
So these are different things you can do. So this is what you can use as a point, because I want to assume that the point we have here, it is a point of an event. Do you get? So you
Yes, sir.
can bring those points together to make your analysis and say this is what happened. Like here, uh, this is just like I want to use this as a crime rate that happened in a particular location. So this is a way you can get that done. Is that okay?
Yes, sir.
So do you have any question now?